Now, let's start off a little bit. If you have your pen and paper, when I write things down, maybe you want to copy down as well. Okay, for things that may be useful to you, I will also let you know. All right. So at any point, if you have any questions, please feel free once again to type inside the chat and let me know. Okay, let's get started. Now, when we approach this chapter on organic compounds, or rather organic chemistry, we are looking at things that are slightly different from all the other chapters that we have learned previously in our chemistry syllabus. So you remember we learned about metals, we learned about acid and bases. Now, this chapter on organic chemistry, we are dedicating our whole time to study this thing called the organic compounds. Now, it turns out in organic chemistry, what we mainly look at is what we call organic compounds. And all of these organic compounds, it turns out, they are all non-metals. Now, this is the first thing I want you to write down, that organic compound, they are all non-metals. Now, the reason why I tell you this is because later when we study deeper into the chapter, there might be some reaction and there might be some things that this organic compound and characteristics that such organic compound have that will always come from the point that it is the non-metal, and that's why they can't undergo some type of reactions, etc. And there are some physical properties, chemical properties. Okay, now, just now I say that organic compound are all non-metal. So if let's say I give you an organic compound like this, when chemistry actually first, or rather when chemists actually first found out about organic compound, they realized that all of organic compound, they actually contain this element, and this element is called carbon. Okay, now carbon is the one in your periodic table, okay, the one, the carbon C, okay? Now, when we look at carbon atom, I want you to understand the chapter on organic chemistry from the simplest point of view, okay? I don't want you to go complicated. There's so many things to memorize. I want you to understand it simply. Now, first thing to do, okay, now when I look at carbon, if I go to my periodic table over here, now you can see over here clearly that carbon is in group 14. Now, can I ask a question then? If carbon is in group 14, how many valence electrons, type to me in the chat, okay? How many valence electrons does carbon have? Okay, the question is, how many valence electron? I see some answers. Thank you so much for the answers. Anyone have any other answer? Okay, some of you say 4. All right, thank you. I received 3 answers. Very good. So you have understand that because it belongs in group 14 and it has 6 electrons in total, what that means is that when we draw a dot and cross diagram of carbon, look here, the first shell can contain 2. This is your chemical bonding knowledge. Second shell can contain 4. So those of you who say 4, well done. Okay, now you can see over here they contain 4 valence electron. And this 4 valence electron is very, very important in what we are going to do when we study organic chemistry. Now let's look at how does this work. Now, if I tell you that there is a carbon atom, now look at here. So sorry. Look at here. If I have 4 valence electron, let me just draw the 4 valence electron like this. Now, if I put in a hydrogen atom, if I have a hydrogen atom over here, now hydrogen atom, everybody know they have 1 electron, am I right? So they have 1 electron over here. Now, when we say that organic compound is a non-metal, then what kind of bonding are they going to undergo? So they are carbon as well as other non-metals atoms that put up together to form an organic compound. So what do you think is the type of bonding? Is it covalent bonding, ionic bonding, or metallic bonding? Type to me in the chat. It is made of non-metal atoms. Okay, different elements, non-metals. Okay, good. Thank you, Jingen. I saw your answer. Kai Ji, I saw your answer as well. Okay, Destiny, I saw your answer. Thank you so much. Is it covalent? Anybody else have any answer? Okay, thank you, Aaron. I see your answer as well. Okay, very good. So all of you are on the right track to say that since there are non-metals elements bonded together, we are expecting a covalent kind of bonding scenario. And that means that, for example, if I have a hydrogen atom over here, when I take this hydrogen atom, I bond it to the carbon, you can see that here, all right, you can see that here they undergo this thing called covalent bonding. Okay, so when we draw this, you can see this is a covalent bond. Sharing of electrons, remember, sharing of electrons. And if I do the same for all the other valence electron of carbon, you will realize that very quickly that carbon can actually bond to 4 hydrogen atoms. Because since carbon got 1, 2, 3, 4 valence electrons, they can bond to 4 hydrogen atoms. Okay, let's understand this from this point first, okay? 1 carbon atom can bond to number 1, number 2, number 3, and number 4. They can bond to 4 hydrogen atoms. Okay, I hope you understand me so far. I'm going to go a little bit deeper. Okay, now look at this carefully. The figure on top shows you a dot and cross diagram. Now, I'm going to translate this into what we call, when we always look at organic chemistry, this is what we always see, is called the structural formula. So, it's going to look something like this. Have you seen this before? Now, this one over here is known as a methane molecule. What does this mean when I draw these lines? Now, you must remember, this one is just a simplification of your dot and cross diagram. It's just a simplification, means make it simple. So you can see over here that these two, the shared pair of electron, is now translated into one single line. Okay, so we must understand the point that this one represents one dot and one cross. Basically, it is one electron pair. Can you see that? So when we draw this structure, sometimes students, they don't get the link between dot and cross diagram and the chemical structure. I need you to be able to see this link so that in exam, you need to tell me, if the question asks you, what does this line represent? It represents the shared pair of electron, or the 2 electrons that are shared between carbon and hydrogen. Okay, can I? All right. Now, moving back over here, we understand that most also contain hydrogen. Most organic compounds contain hydrogen. And some of these organic compounds may contain elements such as oxygen, nitrogen, or halogen. So what are halogens? They are group 17 elements. So if we look at the periodic table, group 17 elements will be as such. It will be fluorine, chlorine, bromine, and iodine. These are your common group 17 elements. They are also known as halogens. Okay, so they are fluorine, chlorine, iodine, bromine, etc. Okay, so these are halogen. Now, when we say contain, that means the carbon is connected to a halogen or oxygen atom, etc. Okay, so this itself is the compound. This itself is the molecule. Can I? All right. Everybody okay? Can give me thumbs up if you are okay. Any question? Okay, thank you so much. Thank you, Aaron, Destiny. Okay, for all of you, thank you. Now, let's move on to this part over here. Now, when we study organic compound, we must always look at it in a classification because not all organic compounds are the same. Now, there are a few differences. Just now we mentioned some contain carbon, some contain hydrogen, some contain oxygen, nitrogen, and other halogens, right? So when we look at organic compound, we always come to this 3 classification over here. The first one over here, all right, is one that says that these organic compound only contain carbon and hydrogen atoms. An example of this will be just now the one that I give you, CH4. This is a methane molecule. They are a carbon and hydrogen only containing species. Okay, now these species have a special name. They are called hydrocarbons. The reason for this is very simple. They only contain hydrogen atom and carbon atom. That's all. Can I? So we call these hydrocarbons because they only contain carbon and hydrogen atoms. Now, under this so-called classification over here, we can further break them down into different families. Now, some are called alkanes, some are called alkenes. Now, I'm going to give you a very example, okay, a very simple example of what does this actually means when we say alkanes, alkenes, alcohol, organic acid. Now, these are all different families. How do we subdivide them into all these family? Okay, so alkanes, alkene, alcohol, organic acid, ester, etc. Now, let me give you a very simple example. Now, in the world, we got many people, right? Many people, they have different surname. For example, some people surname Tan, some people surname Lim, some people surname maybe Muhammad, etc. Now, every kind of surname is come from a family, right? So this family itself, they sometimes have a special characteristics. Now, these special characteristics will help them to be classified under the family. So for example, okay, you go to Tan family, you belong to Tan family, you belong to Lim family, etc. Okay, all these are so-called characteristics that will help this organic compound to be part under a certain family. Okay, so first one we settled already. It's called hydrocarbon. Now, second one, for organic compound, they contain halogen atom. Remember, halogen is group 17 elements. Okay, group 17 elements. They are known as organic halogen compounds. And number three, contain carbon, hydrogen, and oxygen. Some of the example, the family are alcohol, organic acid, and esters. Now, the ones in bold over here are the families of organic compound that we will study. Now, not to worry, if you don't understand this yet, when I go along, you will be able to understand. I go one by one, okay? At any point, if you have any question, once again, I stress you can ask in the chat so that I know how well you are learning. All right. Don't be shy because today everybody is here to learn. Some of you haven't started chapter, I understand, but some of you maybe they start a little bit already. Okay, so that for you to have a better understanding of the chapters. All right. Now, let's move on. Just now I spoke about the families, right? So now in chemistry terms, there is this thing called homologous series. Now, the homologous series is what we call a family of organic compounds. Okay, so for example, if I have alkane, don't copy it down. Don't need to copy down all these words, okay? If you want, you can go back to the recording and see, not to worry, okay? Now, just listen to me. If I have alkane, if I have alkene, alcohol, and carboxylic acid, these are all different homologous series. They are all different families of organic compounds. Now, every family, they will have their own style, right? They will have their own style. So for example, okay, in every family, they will have the same chemical formula. Now, that means that when I have a first member of the family, the second member of the family, the third member of the family, they both all have a pattern in terms of their formula. Later, we will explore this. Now, they will also have similar chemical properties. That means they behave the same way in terms of reactions. And each member of the family differs from the next member by a CH2 group of atoms. Now, what does that mean? We will explore it in the next slide, okay? Now, the gradual change in physical properties down the series. What are physical properties? For example, when we go down the series, that means that we change the member from member 1, member 2, member 3. We go down. What does that mean? The physical properties, for example, melting point, boiling point, volatility, okay, viscosity, all of these factors will change when we go down the series. Now, we also spoke about how each of this can be seen like a family, right? For example, I compare Lim family to Tan family. Now, Lim family, maybe they have a special characteristic. Now, their special characteristic, maybe they all have brown hair. Okay, maybe the whole family all have brown hair. This is their special characteristic. Now, in the Tan family, however, they have black hair, but they have blue eyes. So every member of the family, they all have blue eyes. And what does this actually tells you? Now, each family, they have a different characteristic that will tell you what family it belongs to. So if I see a compound, when I look at that characteristic, it can help me to identify whether it come from Lim family, it come from Tan family, come from Ko family, etc. Okay, now in chemistry, all these special characteristics, there is a special name, and they are called functional groups. Okay, they are called functional groups. Basically, it is the characteristic of each family. Now, in functional groups, we are talking about a group of atoms or a special characteristic that each compound has for homologous series. Okay, so alkane got their special characteristic, alkene got, alcohol got, and carboxylic acid also have. Now, these are called functional groups. Okay, the special characteristic. Now, I'm going to give you an example of what are these functional groups. Now, first, we talk about alkane. Alkane is the first one that we learn. Now, it turns out alkane are very boring people. They don't have any functional groups. So there is, when we see alkane, they are nothing special. There's no way for us to identify them except to look at other functional group and say that all the other ones are not present. Hence, I say this is a alkane. They are very simple, okay? Now, what about alkene? Alkene is the next family. Now, it turns out alkene have this special characteristic whereby they have a carbon to carbon double bond. Okay, we put a double bonds, look like this. They have a carbon to carbon double bond present in the molecule. Okay, they have a carbon to carbon double bond present in the molecule. Then we will call this alkene. Can Now, for students who have just joined us, we are currently talking about homologous series and functional groups. Okay, now, alkene. Next one, we talk about alcohol. Now, alcohol is something that's a little bit special. They have this group called OH functional group. Okay, now, when you see that a molecule is attached to this OH functional group over here, we immediately can say that it is an alcohol. Now, what about the next one? It's called carboxylic acid. Now, carboxylic acid, I say, is very, very cool. Why I say so? Because their functional group actually looks like this. COOH. Not COOL, COOH. Now, if I have a molecule that is attached to this COOH, okay, we call this a carboxylic acid. We said that they come from the family of a carboxylic acid. So all these are their distinguishing characteristic. Okay, all these are their distinguishing characteristic. Now, why? Okay, alkane. Some of you may be wondering what is the big X sign over here. Just now we talked about the methane molecule, right? Methane molecule. How does methane look like again? Methane looks like this: CH4. Now, CH4 over here, you can see clearly that there is no carbon to carbon double bond. Don't have. There is no OH group and there is no COOH. So hence we say that this is an alkane. And so far, any question? No question? Oh, okay. If okay, can give me a thumbs up so I know that you are good to go. Okay, thank you so much, Kaiji. Thank you, Red. Thank you, Destiny. Thank you, Aaron. Okay, thank you, Mike. I see your surprise face as well. If you have any question, please type inside the chat so that I know. Okay, let's move on. Now, once you have looked at the different families, let's explore each family in a deeper scale. Okay, let's explore the family in a deeper scale. Now, don't copy, don't copy. I tell you what is the important thing to take note, then you copy down. First, we are going to talk about the first family, also known as alkanes. Okay, this is the word alkanes. Now, when we talk about these topics on alkanes, we are looking at a family of what we call saturated hydrocarbons. Now, can anybody tell me in the chat, what does hydrocarbons mean? And carbon atoms. And the key word here is only. They only contain these two types. Okay, they only contain hydrogen and carbon. And that is the reason why we say that they are hydrocarbon. Only have hydrogen and carbon. Now, does anyone have learned this term called saturated? Anybody know what is this term saturated? What does saturated means? Okay. Okay, Destiny, I see your answer. Hey, Mac, I see your answer as well. Okay. Anyone else? Okay, most of you are a little bit confused. No worries. Now, saturated simply means carbon to carbon single covalent bond. Okay, carbon to carbon single covalent bond. So when we say that this molecule is saturated hydrocarbon, that means that the molecule itself contains single bonds between carbon to carbon atoms. So what does that mean? If I have a pictures of an alkane, that the one over here, this is an alkane because it contains carbon to carbon single bonds. Can I? Okay, with this understanding, now we talk about how each member differs from the member before it by CH2 atom. Okay, now, just now we have mentioned this already, that carbon can only form 4 bonds. Am I right? So remember this, whenever you go to covalent chemistry, or rather covalent bonding, the important thing for you to take note is that carbon in organic chemistry only can form 4 bonds. This is something, this is a trick for you for organic chemistry to help you not make any careless mistake. Okay, carbon can only form 4 covalent bonds. Now, with this understanding, I'm going to draw one alkane. Okay, I'm going to draw the simplest one. Okay, we have a carbon. And since because we say that they are hydrocarbons, every other bonds around it will be a hydrogen atom. Can you see that? Because carbon can only form 4 bonds, hence I put 4 hydrogen around it. Now, with this understanding, the next, this is number 1. This is member number 1, okay? Member number 1. Now we move on to member number 2. Now, how does member number 2 looks like? I'm going to give you this. I have a carbon over here. They are going to be bonded to a hydrogen. This is called a CH2 group. Okay, CH2 over here. I'm going to perform some magic. You can see over here that if I have this hydrogen that I take away, okay, I move this hydrogen away. Then later, I take this hydrogen away first. I take this group, I put inside here. Okay, I put here. Then I put this back over here. Now you can see over here that I have inserted the CH2 group. So when we insert a CH2 group, we are creating the new member. Okay, we are going to the new member. So just now, I have one carbon, this is a hydrogen, there is no CH2 group. we will call it member number one. Okay. If I have one carbon, it's called methane. Okay, if I have one carbon. Now, number two, since now I have two carbon, the name for it will change as well because they have two carbons now. They are the next member, member number two. The name will be ethane. And it turns out as we add more carbon, three carbon is going to be called propane, and four carbon is going to be called butane. Now you can see over here there's a pattern. Because they are all alkanes, now organic names are made of prefix and suffix, means front and back, okay? Now prefix is over here. For example, METH is a prefix, ETH is a prefix, PROP is a prefix, and BUT is a prefix. Now the prefix tell us how many carbon atom does the molecule have. Okay, so this tells us, okay, there's one carbon atom. Now, I tell you it's a one carbon atom, and what is its family? The suffix will tell you the family. So this is an alkane family. So when I say methane, you will tell me that it is a one carbon alkane. One carbon alkane. Okay? Now, each carbon atom have used all the valence electrons to bond with four other atoms. Okay, each valence, or rather each carbon atom use up all the valence electrons to form four bonds. Basically, you can see over here, this one over here, that you see this carbon, they have 1, 2, 3, 4. They have four covalent bonds. We look at this carbon over here, they got 1, 2, 3, 4 covalent bond also. Okay, so if this is the case over here, then we understand that they are saturated because they are all connected by carbon-carbon single covalent bonds. So far, so good. Any question? No question, can give me a thumbs up so that we can proceed on. Okay, thank you, Aaron. Thank you, Destiny. Thank you, Haixi. Okay, thank you, Red also. The student who just joined, do you have any questions? No, no questions. Okay, I'll move on. Now, let's look at the chemical structures of different organic compounds. Now, we look at alkanes chemical structures. Very first up, I want to let you know that this is known as the name, or sometimes we call it the chemical name. Now, this one over here, the CH4, is known as the molecular formula. Okay, now this is called the full structure formula. And one over here is called the condensed formula. Now, there's so many different types of formula. How can we understand each of them? I'm going to let you know now. So one means the member or the number of carbon atom. Okay, now, if I got one carbon atom, okay, can you understand with me over here that if I have one carbon atom, the name of it is called METH. Okay, METH. The suffix is ANE because it's an alkane. So hence I call this methane. Okay, we have also learned this in the chapters, okay, other chapters, okay, methane. Now, molecular formula of methane is CH4. Now, alkanes have this general formula. I say just now, right, about general formula. Now, alkane got general formula of CN, this one write down, H2N plus 2. Now, what does this formula actually means? Basically, if I tell you I want to find a one carbon alkane, if I have one carbon alkane, I take N equals to 1, so it will be C1, H to multiply by 1 plus 2, it will be CH4. This is help me find the formula. Okay, sorry, this one over here, the formula of the alkane. Now, after I've gotten the molecular formula, I can draw the full structure formula. So I got the carbon in the center, I got 4 hydrogen that are sticking out. This one everybody knows. And once again, one stick over here represents a dot and a cross. Now, what does condensed structure formula means? Now, these two actually looks quite similar. But what we're going to do is when we increase the number of carbon, we look at member number 2. Okay, member number 2, okay? Now, member number 2, does anyone remember the name? Anyone can tell me inside the chat. If I have a 2-carbon alkane, what do I call it? Very good. Okay, ethane. Well done. Okay, so ethane. Now, molecular formula, very simple. N now equal to 2. So it will be C2H6. Simple math. Okay, everybody can do one. Now, when we look at full structure formula, now if I got 2 carbons, remember we start from the carbon. Carbon connect to carbon. Okay, so remember this is a saturated hydrocarbon. Carbon to carbon, single covalent bond. Okay, sorry, this one not OFC, not of course. This one means of carbon atoms. This is carbon atoms. Can? Mac, is that okay or not? Carbon atoms, sorry. Maybe you'll interpret as of course. Okay. OFC stand for number of carbon atoms. So this is 1 carbon atom. This is 2 carbon atom. Okay, now back to this. Carbon to carbon single bond. Now remember, every other bonds that are not drawn yet, they are all hydrogen. I fill in the hydrogen and I will realize that since this is a C2H6 is an alkane, there will be 6 hydrogen atoms, 2, 3, 4, 5, 6, and there'll be 2 carbon atoms over here. Now, let's look at what does it mean to be a condensed formula. Now, chemistry, or rather, when people study chemistry, they are very lazy one. So they want to try and find ways to actually make the make life easier. Okay, make life easier. Now, one of the ways that they did that was through this thing called a condensed formula. Now, chemists don't have a lot of time. They draw this one, they still need to draw the stick, right? They still need to draw the bonds. Now, condensed formula allows you to look at the full structure without the need of drawing the whole structure out. Now, imagine if I have a molecule is C10H22. I will have a very, very hard time trying to draw. I will draw 10 carbon atoms like that. Well, it's going to take me a very, very long time. So what chemists came out with is called the condensed formula, which allow you to represent the full structure formula in terms of a sequence. So you can see over here, simple, not so difficult. Now, we always go from left to right. We read a structure from left to right. Now, on the left side, I always start with the first carbon. Now, remember, organic chemistry is always about carbon. We look at the first carbon. Now, this carbon over here, it is attached to 1 hydrogen atom, 2 hydrogen atom, 3 hydrogen atom. So you go from left to right, okay? Now, this one is CH3. Basically, I'm writing down what is in the first carbon atom. What is connected? Okay. Now, next, I move right side. Once I'm done with the first carbon, I go to the second carbon atom. Now, second carbon atom is 1, 2, 3. And hence, the formula will be CH3CH3. Now, you can see this actually, doesn't this match exactly what is shown over here? We have a CH3 and we also have a CH3. So basically, instead of chemists drawing this whole thing out, they just represent this with a condensed formula. Now, let's try this for 3 carbon. It's called propane. Now, can anybody tell me what is the molecular formula quickly? Molecular formula for propane. Using my general formula, okay? My general formula is over here. Okay. Ray, you try again. Maybe your math got a little bit of error. Okay. Kai Ji, I see your answer, correct? Okay, Aaron, I also see your answer is correct. Destiny, I think you typed wrong. Yes, C3 is correct. Okay, so it's C3H8. Yeah, correct. Okay, so why? Because this is 3, 2 multiplied by 3 plus 2. So this is 4 plus 2. Sorry, my math failed. 6 plus 2, which is 8, equals to 8. Can I? Okay, now, since I give you C3H8, can you try drawing? Can you try drawing the full structure formula? Give you 1 minute to try draw the full structure formula. Remember, always start from the carbon. If I got 3 carbon, I draw 3 carbon in one line first. Okay? Try. Hey, don't worry. I know some of you are slower, not to worry. Some of you are faster, not to worry as well. Just try to do it at your own pace. Okay, once done, type done in the chat. For those of you who are stuck, look at my screen. Those of you who are okay, don't look. Just do, just draw. Okay? Wow, Mac very fast. Destiny also very fast. Done already. IT also very quite fast. Done. Red also quite fast. Done. Okay, that's great. Now, look at this over here. Okay, I just draw the structure. When we draw organic structure, remember the process is always this. Okay, when we draw organic structure, number one, what do? We draw the carbon chain. That means what? If I got 3 carbon, I draw the 3 carbon. If I got 2 carbon, I draw the 2 carbon. Now, number 2, later we will learn this thing called isomer. We will check for isomer. And then number 3, we will fill in the hydrogen atoms. Okay, we fill in the hydrogen atoms in the remaining positions. Okay, now, with this, try to get the condensed formula and type to me in the chat. Go from left to right. Remember, go from left to right, okay? Try to get the condensed formula for propane. Very fast, very fast. Wow. Mac very fast, Destiny very fast, Aaron very fast, Rick very fast. Very good, fantastic. Now, very good. So we go from left to right. First, we have a CH3. You can see over here, we got the CH3. We have a CH2 followed by a CH3. Okay. So sorry, the pen not working. Give me a moment. Nice. Okay, CH3, CH2, CH3. Okay, so you can see clearly from here, right? We have a CH3 group followed by a CH2 group followed by a CH3 group. Now, with this understanding, we're going to move on to the next homologous series. Okay, alkanes done already. Any question? Okay, give you 1-2 minutes. If you want to copy down some things, you can copy down. If not, then we move on to alkenes. Can Okay. If you are all good, can give me a thumbs up. Okay, thank you, Aaron. Okay. Oh, Max say can go to a previous slide. She wants to copy something. Okay, please. Okay, Aaron, okay, but she's still okay. Can I? Okay. Kai-Chi, can I answer your question? Okay. The rest of us okay? Okay, come. Now, I would like to just do a short recap before we move into alkenes. Okay, about this concept of homologous series again. Now, for new students who have just joined us, okay, some of you maybe haven't heard this part yet. No, not to worry. Come, let's recap this. Now, homologous series is the family. So, for example, Tan, Lim, Mohammed, Ho. Okay, all these are surname of family, different family. Okay, Tan family, Lim family, etc. They are the family. So alkane, alkene, alcohol, carboxylic acid, they are the family. Now, every family, they got their own special characteristic. So for example, Tan family, they got all blue eyes. Okay, they got all blue eyes. Now, for organic, also same thing. For example, alkene, they got this thing called a functional group. Every homologous series, they have the special characteristic. It's called a functional group. So for alkene, the functional group will be a CC double bond. This is their special characteristic. Okay, functional group. Can I understand this? Don't worry if you don't understand, you can still ask questions. Okay. Yeah, if you understand this, then okay, we move on to alkenes. Okay, now let's go to alkenes. Now, so sorry, we haven't go to alkenes yet. We look at alkenes first. Continue. Now, alkenes, I haven't explained finish. Okay, now alkenes is physical properties, talking about alkenes. When we look at physical properties, now, I want to stress that organic substance don't like non-organic one. So water is a non-organic substance, means they're polar substance, okay? Now, they are a water-based solvent. Now, they are insoluble in water. That means that because they're organic don't like non-organic, hence they don't like to dissolve in water. Okay, Mac, you give me a moment later, I go back to the previous page, okay? Now, let me explain this first. Now, after we learn that it is not soluble in water, we learn about this thing called soluble in organic solvent. Organic like organic. Organic don't like non-organic, okay? Now, organic like to interact with organic. So hence, alkanes, they are able to dissolve in organic solvent. Now, solvent basically is a liquid that allows you to dissolve your solute. Now, in this case, the solute is your alkane. Can? Now, another physical properties that we will study is when we go down the homologous series. Now, homologous series, remember down the homologous series, that means the number of carbon increase. Remember, member 1, member 2, member 3, member 4. Whenever we go up by a member, whenever we go down by a member, so 1 to 2, 2 to 3, they always increase by what? CH2, right? They always increase by CH2. So we can say that since the number of carbon atom increases, the number of carbon atom increases, what does that mean? When I have a more carbon atom, the relative molecular mass, you remember how heavy the molecule is? If I got more atom, of course, it's heavier, right? So the mass of the molecule will increase. The size of the molecule will also increase. Because I got more atoms now. More atoms make up the molecule. Just now the molecule is so small. But now I got so many atoms. Now the molecule is very big. Okay? Now, when the size and the mass of the molecule go up, the force of attraction between the molecules also go up. Now, remember how does this work? Okay, now what is this force of attraction we are talking about is, for example, when I have a H2O and I have a H2O. Remember in chemical bonding, we always talk about this weak intermolecular force of attraction. Weak intermolecular forces of attraction. Now, similarly, since alkanes, they are simple molecular structure. Okay, they are covalent molecule, they are small covalent molecule. The force of attraction is the weak intermolecular force. Then since they are bigger and bigger, the force that they attract with each other is bigger as well. Now, remember, if the force go up means when I need to increase this temperature, or rather when I need to boil it or melt it, it will be a higher temperature. It will be at a higher temperature because I need more energy. I need more energy to overcome the force of attraction. Hence, the melting point, boiling point will increase. Okay? Now, I have a question from Meg. Okay, she asks, why does the force of attraction increase? Okay, you see, I remember. Now, we learned this in chemical bonding. Okay, now let's start, or rather, let's compare this. If I have a hydrogen molecule, this is a HH, hydrogen, hydrogen gas, hydrogen, versus if I got water, okay, water molecule, like that. Now, when I have these two, right, you can see that both of these agree with me that they are all simple molecular structure. They are all simple molecular structure. Now, every simple molecular structures, they will have a weak intermolecular force of attraction. Now, why? Because they have a mass, right? When they have a mass, they tend to like to stick together. Okay, they tend to like to stick together. Similarly for this, if I have a water molecule, there do exist a weak intermolecular force as well. Okay, now, but it turns out because this is a larger molecule, bigger mass, they like to attract, or the force that they attract each other, they stick together with, is actually greater. Okay, greater than the one of a smaller molecule. And hence, when the size and mass of molecule increase, the force of attraction also increase. And I hope you get me on this part. Now, there are other factors like density, viscosity, and flammability. Now, this one, because the molecule is bigger. The molecule is bigger now. There are so many atoms. There are so many different atoms. The density increase. Okay, density increase. Now, viscosity is because of the fact that, okay, they are now thicker and more difficult to flow. Okay, and flammable will go down because if I have a small, for example, CH4 versus a C10H22, now you can see that because this one, when I do burning, when I burn it, it's very easy to become carbon dioxide and water, right? Because only got one carbon. The amount of force that each covalent bond holds is less versus if I have a very big structure like this. Okay, so all these are not so important. It's just for your knowledge. But most important is you must tell me how does the size and mass affect the force of attraction, which in turns affect the amount of energy I require to overcome the force of attraction to melt or to boil. Okay? All right. Now, physical properties done. Let's look at reaction. Now, this is the most important part. Okay, this is the most important part for the chapter. Now, reactions of alkanes. Now, we understand that because alkanes are saturated compounds, remember what a saturated means? Saturated means carbon to carbon, single bond only. Single covalent bonds. Okay, so single covalent bonds. That means that if I have an alkane over here, can you tell me this carbon is already bound to 4 different groups? Tell me in the chat, yes or no. Can it add one more atom? Can we add more atoms to it? Can we add more bonds to it? Can we attach more bonds to it? Is it a yes or is it a no? Very good. Most all of you say no, right? Fantastic. Because carbon can only form 4 bonds. You remember that? Any carbon with 5 bonds, immediately you tell yourself wrong already. Cannot. So hence, they are generally unreactive. But they still undergo combustion and substitution reaction. Okay, since now we cannot add another bond, what we do is that this atom, for example, I can take another molecules or rather another atom. This atom will come here. So sorry, the atom. Oops. These atoms over here, what they will do is that it will substitute the position of this hydrogen that was originally here. So that means that this hydrogen is going to go away. And this big molecule over here, okay, they are going to substitute the position of the hydrogen where it was just now. Okay, so this is what we call a substitution reactions. Now we're going to learn how does this reaction work. Okay, can I? All right, now moving on. First one is a very standard because they are carbon. Okay, remember organic compound, they are mostly carbon. Carbon react with oxygen, they will give you carbon dioxide. Now, remember this, your reaction carbon plus oxygen give you CO2. This one everybody knows. Okay, now what people don't know is because these organic compound contain hydrogen, then you tell me they got hydrogen, how does it affect? Right? So I'm going to tell you that since there is a hydrogen, now what is going to happen is that hydrogen is going to react to form water. So the carbon, look at here, carbon over here. This one don't need to copy. This one you just understand can already. The next one I want you to copy, okay? The reaction with chlorine, but don't copy first. Listen to me on this first. Combustion. Now, if I have this C2 over here, okay, C2 over here, it becomes carbon dioxide. Can you see that the hydrogen here forms a bond with oxygen to form water? Okay, so carbon become carbon dioxide, hydrogen become water. This is the first reaction, combustion reaction. Next, reaction with chlorine. Now, this is a very special reaction. This is called substitution reaction. Okay, please write down this term. They are called substitution reaction. This is a reaction that only alkane can do. Alkane can do substitution reactions. Now, I'm going to show you how does this reaction work over here. If I got a methane molecule, okay, I give you an example, methane again. Now, methane is over here. Can you see that methane have 4 bonds, or rather the carbon in methane have 4 bonds? Now, if I have a chlorine over here, okay, Cl, chlorine gas, remember chlorine gas is Cl2. Chlorine gas is Cl2. What is going to happen is that chemists, they take UV light. They got nothing better to do. They take UV light, they shine on the chlorine. And what happened, they found out is that the chlorine-chlorine bonds is going to actually break. The UV light provided enough energy to break the chlorine-chlorine single bond. Next, since the chlorine are now free from each other, this chlorine atom, it turns out, will come and kacau this hydrogen atom. Okay, so how does it work? So this chlorine atom, nothing better to do, they come to the methane, okay? And then after that, it will so-called kacau the hydrogen atom. And then what happened next? Chlorine come here, hydrogen scared already, hydrogen run away. Chlorine will take the position where hydrogen used to be. Okay, now what happened to this hydrogen in the end? This hydrogen cannot be floating around. Now it come back and it form a bond with chlorine, become HCl. Remember, hydrogen chloride. Okay, so in this process over here, you can see how the chlorine originally is like that. Once I shine light, they will come and steal the position of the hydrogen. Now, so now we end up with this product of HCl. Now, I got another question. If I got ClCl again, I got one more molecule of chlorine, then I shine light again. Then after that, since I shine light, the bond will break. Since the bond break, what happens? This chlorine come and kacau the hydrogen again. Hydrogen run away. Chlorine take the place. Hydrogen come back over here. Then can you see that in this case over here, if I got more molecules of chlorine, they can take the place of all the other hydrogen in the alkane. So this is called substitution reaction. The hydrogen will go out, the chlorine will come in to take the place. This is called substitution. Okay, one go out, the other one come in. Now, so it's important for you when exam tests, you must tell them it is ultraviolet light. Now, when they ask why, you say that the ultraviolet light is needed to start the reaction for the substitution of the chlorine atoms. Basically, whatever that I just draw over here is summarized in this reaction over here. If you are a visual learner, then you look at these visual creatures. Humans are always visual creatures. Okay, you look at this, you will understand. You look at this equation, you cannot see how the chlorine move. I show you exactly how the chlorine move. Okay, now, so what are the substitution reactions? Okay, the definition is an atom or group of atom replace other atoms in a molecule. Basically, one replace another. That's it. Okay, any question about substitution reactions? Okay, I have a question from Meg. Meg asks, why can only alkane do substitution and not other functional group? Okay, why not other homologous series can do substitution? So for example, alkene, alcohol cannot do substitution. Why only alkene can do? Because remember, alkene, what are they? They are saturated hydrocarbons. Remember, alkanes, they are always saturated hydrocarbon. Now that means that carbon have already formed all the bonds, right? 4 bonds to 4 different things. Later we look at carbon-carbon double bond, we'll realize that actually it is not substitution, it is another process, which we will cover later. It's called addition. Okay, because they are, sorry, what am I writing? Saturated hydrocarbons. Okay, saturated hydrocarbon. Anyone have any questions? All doing well so far. Okay. Okay, Okay, let me move on. Those of you who need to copy down something, please copy. Give you 5 seconds. Okay, after this, we move on to alkenes. Okay, never mind, not to worry. Meg, if you don't understand the explanation, later we cover alkenes first, then you understand. Okay, we try to understand again. Okay, alkanes, just remember, alkanes is a family, right? And every family, they got their special characteristic. They got what they like to do. So in this case, alkane like to do substitution, okay? Because they have all single bonds, because they cannot do any addition of any other new molecules. Therefore, they can only do substitution. They can only take out one, then replace one new one. Later, we look at the other family. Then you will see that actually, they don't need to take out one to put in a new one. Okay? Yeah. Okay, not to worry. Okay, just hold on with your question. Then we answer that in the next part. The rest of us, are we okay? Yeah. Okay, let's move on. Now, we talk about alkenes now. Now, just now, we look at alkanes already. Alkane is one family. We study the family. We study what do they like to do? They like to do substitution. We study the special characteristic because they contain only carbon-to-carbon single bond. We call them saturated. Because they only contain hydrogen and carbon, we call them saturated hydrocarbons. Okay, alkenes. Now we move on to alkenes. Okay. Now alkenes, they are also another family, homologous series. They are unsaturated hydrocarbons. Now, hydrocarbon, once again, same thing. It means hydrogen and carbon only. Now, the term unsaturated over here means there is a presence of carbon to carbon double bond. Okay, now later I'm going to explain to you what does this carbon to carbon double bond means. Okay, now the general formula for alkenes is CnH2n. This one you just remember. Just now alkanes is got +2. Alkenes don't have +2. Okay. Now I'm going to now teach you what does the carbon-carbon double bonds actually means. So now I have a carbon atom over here. Can you look at this over here? This is a carbon atom. And I have another carbon atoms that is over here. So sorry, Okay, now I got two carbon atoms over here. Now this is a carbon atoms. Normally, if I bond the two carbon atoms together, they will share one pair of covalent bonds. That means that they will have another 3 electrons on the outside. Then don't copy it down first. You look at this first. Okay, look at this first. This is what we will normally have. Okay, never mind. Let me just zoom in. Okay, zoom in. Let's zoom into this part. Okay, let's see over here. Now, because they, can you understand this? Because they only share one pair of electrons, CC single bond. Can you see that they can bond to 1 hydrogen, 2 hydrogen, 3 hydrogen, 4 hydrogen, 5 hydrogen, and 6 hydrogen. This is C2H6. Remember? So this is CnH2n plus 2. This is 2 ma. Okay, the N is 2. So C2H6. But in alkenes, on the other hand, it turns out instead of them sharing only one pair of electrons, instead of the carbon only sharing one pair of electrons, they share 2 pair of electrons. They share 2 pair of electrons. That means they share 2 pairs over here, and they can only attach themselves to 1, 2, 3, 4 hydrogen atom. Because you realize over here, this electron no more already, they put inside sharing already. So when we were to draw the structure, it looks something like this. C double bond C, link to hydrogen, bond to hydrogen, bond to hydrogen, and bond to hydrogen. Now you can see over here that because of the fact that there is these double bonds over here, okay, we call this an alkene. And this is a C2H4 which follows the formula CnH2n, where n equals to 2. Can see that? Can see the link between these two? Can I? Okay, now I'm going to zoom back out and explain this slightly further. Now, same goes for this. Each member differs from the member before it by CH2. So we got member 1, member 2, member 3, member 4 for alkenes as well. Now, each member contains this thing called the unsaturated carbon-to-carbon double bond, which is what we have seen over here in blue and pink color. Now, because of the fact of this, they have more reactions than alkanes because there's these CC double bonds. Now, originally, can you see over here, if let's say I got only a single bond, then if I got only a single bond, there'll be hydrogen everywhere. But what is going to happen is that if I have something, a compound that has a double bond, what is going to happen is that if let's say I have other creatures outside, for example, I got chlorine, okay, a chlorine atom. Now, instead of me trying to substitute it away by taking out a hydrogen and putting the chlorine in, what is going to happen is that this thing can actually break the double bonds. Now, remember, if I break the double bond, I can get chlorine to attach one here. I can also get another chlorine atom to attach over here. Can you see that? So they can undergo addition reactions. They don't need to undergo substitution because the hydrogen can stay there, no problem. What is going to go is just because the double bond is going to disappear. Once the double bond has disappeared, I free up 2 more spaces for me to add in new atoms. And I hope that you can understand this. Okay. So what is going to be explained is that ethene is the most important alkene. Now, ethene is 2 carbon. Okay. It is used to make many useful chemicals and products. This is just for your awareness. Okay. So unsaturated compound means because it's carbon-carbon double bond, not all the carbon atoms are bonded to 4 other atoms. They are only bonded to probably 3 other atoms, right? Can you see carbon to carbon double bond? This carbon over here is only bonded to 1, 2, and 3. They are not bonded to 4. Okay? Although they have a double bonds between the carbon to carbon. Now, if you're okay with this, I'm going to look at the nomenclature again, okay, which is about the structure. Now, first, if I got 2 carbon, it's called ethene. Now, can I have a 1 carbon alkene? Cannot. Why? Because for me to have the CC double bond minimally, I need to have 2 carbon. Can you see that? 2 carbon. And can anybody tell me what is the general formula for alkene? Just now I say already. Type in the chat for me. Anyone have any idea? CN. Okay, very good. Okay, thank you, Destiny. I see your answer. The rest of us? Okay, very good. Well done. CnH2n, where n is the number of carbon atoms. Okay? Now, first off, we look at the basic one. Start with 2 carbon. It's called ethene. 3 carbon is called propene, etc. Now, 2 carbon, the molecular formula is C2H4 based on the CnH2n. When we draw it out, you will realize that for alkenes, we draw it like slanted like that. Why? Because you see, if I only have 3 bonds around the carbon, actually now it's a 60, 60, 60 ma. Sorry, it's 120 degrees. Okay, because the angle is now changed. Okay, now we draw it slanted to represent the fact that they only have 3 bonds. So 1, 2, 3. They only bonded to 3 other atoms. Sorry, I correct myself. 4 bonds. 1 is a double bond. 2 is a single bond. So they got 4 bonds, but they only bond to 3 atoms. Okay, 1 atom, 2 atom, and 3 atom. This carbon over here. Okay, now when we write the condensed formula on this case, what we need to do is we always go from left to right. It's the same, but because we have a double bond over here, what is going to happen is that we will first write down the CH2, which is over here. Now, between the carbon that have a double bond, we will illustrate it by putting in a double bond over here. And then after that, we continue with this. Because if you write CH2, CH2, nobody will know it's an alkene because you never tell me got double bond. I will just think, okay, this one is just a normal. Normal. Okay. have a question as well from Meg. Meg asks, if let's say I draw the structure like that, is it wrong? No, it's not wrong. It's not wrong, okay? It's not wrong, but I would recommend students if when they are drawing alkenes, they draw slanted. Why? Because when I draw slanted, I know very clearly it's an alkene. But if I were to draw it like that, then some student will go and see, why does it look like that? Then you add me another two more hydrogen over here. Then you realize that you count the number of carbon, okay, number of bonds. This carbon have 1, 2, 3, 4, 5. Can carbon have 5 bond? Cannot have 5 bond, right? So to minimize the error, I will recommend my student to always draw like that. So that you can see this is an alkene. Okay, minimize careless mistake. All right, moving on. Now, ethene done already. Now we move on to propene. Okay, now propene follow the same formula, C3H6. Now you can see over here that because if it's a C3H6, the carbon, or rather the position of the double bond, okay, is here. And then there is only one double bond. So for any alkene, only got one double bond. It is between the first and the second carbon over here. Okay, so this is propene example of structural formula and how you write the condensed formula. So left to right again, left is a CH2 followed by a double bond. Can see the double bond over here. After the double bond, we have a CH. Then after the CH, we have a CH3, which is illustrated over here. Can I? Okay, now with this understanding, now let's move on to the physical properties and the reactions. Now, physical properties of alkenes very standard, same as alkanes, because they are all hydrocarbons. Because they are all hydrocarbon, they have a similar pattern. But because of the fact that they got a carbon-to-carbon double bond, okay, carbon-to-carbon double bond is called more reactive. Okay, it's more reactive. Alkenes are more reactive than alkanes. Okay, Mac is asking, can show how does one carbon atoms look like? Structural formula for it. Are you saying for alkenes? Mac, you mean one carbon atoms for alkenes? Okay, remember, just now I explained this. Carbon to carbon double bond, right? For alkene in this family, I need a carbon to carbon double bond. If I need a carbon to carbon double bond, I cannot have a one carbon atom alkene because they cannot have this. So minimal for alkene must have two carbons, okay? So that I can have the presence of a CC double bond. Can I? So alkene always start from two carbon. Understand this? Okay, good. Okay, back over here. Now, reactions of alkenes. Number one, combustion. Now, combustion, very standard. I got something with carbons. Carbon combined with oxygen, give me carbon dioxide. Hydrogen combined with oxygen, give me water. This is a standard reaction, combustion. Now, next, because of the fact that they are a CC double bond, they can do addition reaction. Instead of doing substitution, alkenes undergo this thing called the addition reactions. Now, addition reactions basically means that when I have an alkene, when I add another molecule to it, it will integrate, remove the double bond to form a single bond and give me one single product. Okay, so basically if I got a molecule plus an alkene, it will give me one single product. Okay, one single product. Yeah. Okay, now let's move to examples. Now, I have a lot of things to copy here, not to worry. Let's try, we'll do it one by one. Okay. Let's approach this one by one, okay? Now, the first addition reaction you learn is known as hydrogenation reaction. Okay, write this down first. Hydrogenation reaction. And it happens in the presence of nickel catalyst. And so far? Yeah. Hydrogenation reaction happens in the presence of nickel catalyst. Now, as the name suggests, When I have an alkene, it is a C-C double bond bonded to hydrogens. When I undergo the hydrogenation process, basically I'm putting more hydrogen to this. We are putting more hydrogen onto the alkene. So how does this work? You can see over here, if I have an ethene molecule, when I have hydrogen over here, what is going to happen is that in this reaction, the bond between the two hydrogen is going to break. The carbon-to-carbon double bond is going to break. And this hydrogen will come here to attach itself here. This hydrogen is going to go there to attach itself there. And in the end, we will form something known as an alkene. Okay, so if I got alkene, I want to make it become alkane. I go through this process called hydrogenation process. Okay, vegetable oils are alkenes. Margarine is an alkane. Okay, Mac asked why is it nickel catalyst, right? Because nickel, remember every chemical reaction got catalyst. Now, can anyone tell me, right, type into the chat, what does a catalyst do? What is the definition of a catalyst? It takes you a little bit. What does catalyst mean? Those of you who copy down your this one first, okay, copy down first. Then after you tell me, what does catalyst mean? Catalyst mean heat No lah. I don't want example of catalyst, okay? I want what is a catalyst. Good, good. Good. Yes, okay, good. So it is something that increases the rate of reaction. Okay, how? By providing, this is the full definition, providing an alternative reaction pathway. Okay, and this alternative reaction pathway, the special characteristic is that it has a lower activation energy. Okay, lower activation energy. Good. Okay, they are something that you add to a reaction to provide an alternative reaction pathway, okay, with lower activation energy. The catalyst is not used up at the end of a reaction. It is just there to help the reaction become faster only. Yeah. Okay, so in this case, in this reaction, they found that nickel is a very effective catalyst. Okay, just a recap on your speed of reaction chapters as well. So you can see all the chemistry chapters are very interlinked. Okay, even though we are on organic chemistry, we still talk about speed of reaction. We also link to the fact that carbon, okay, the chemical structure of it allows it to bond to 4 bonds only. Okay, all right. Ken, any questions? Okay, Meg, to answer your question, every reaction has its own specific catalyst. For example, if I look at ammonia, manufacture ammonia Haber process, I use what? Finely divided iron catalyst, right? Finely divided iron catalyst. Okay, for catalyst, we always talk about, or rather, this one is not in O level. Catalyst is a surface. Okay, catalyst is a surface, it's a porous surface that allows the molecule to fall there. Because it is porous, it helps to bring the molecule closer together. And that is how they speed up the reaction. They put people together or put the two reactants together to let it react faster. Okay, so in this case, nickel matches the molecular sizes of these elements, and that is the reason why they use nickel. Okay, this is just for your knowledge, not test in exam one. This one is just extra knowledge for you. Yeah, because this one Meg was asking, why is it we use nickel catalyst? Okay, good. Keep your questions coming. Okay, good. All right. Now, next one we move on is called addition of bromine. Okay, just now on top we talk about hydrogenation, means we add hydrogen. Now, addition of bromine, this process is called bromination. This is called bromination. Now, in the process of bromination, basically we are reacting alkene with bromine solution. So you can see over here that if I have an ethene, I use the same ethene like I used for the top one just now. When they undergo bromination, what is going to happen is that this reddish brown bromine, okay, when it's Br2, okay, they are going to be broken up. Then after, what is going to happen is that the double bond is going to break. One is going to come here. The other one is going to go here. One go to each carbon. And they're going to stick themselves there. So you can see over here that because of the fact that the bromine structure, the Br2 is broken, the reddish brown will no longer be reddish brown. It will just turn colorless. And then they will form me what we call a dibromoethane. Means this alkane have two bromine, dibromoethane. Okay, basically a bromine molecule is added across the carbon-carbon double bond of the ethene molecule. Remember, this is an alkene. When we do a reaction to form a product, two reactants become one product. You will realize that the double bond is gone. There's no longer a double bond, and they will form you a saturated compound. Okay, so brown solution turn colorless. Now, this reaction, bromination, is very, very important. Put a big star at wherever you are copying now. Bromination reaction is super important. Okay, let you copy first. Okay, once again, saturated compound means what? Carbon to carbon single bond. They have no more double bond, only single bond. S for saturated, S for single bond. Okay, single bond. Yeah, from double bond becomes single bond. Now, why I say this is very important. I give you a scenario, okay? I give you a scenario. I got compound A and compound B. Now, I know that both of these, okay, if I am inside a dark room, this is a dark room. Dark room. Now, A and B. I tell you that A and B, one of it is an alkane, one of it is an alkene. Can you tell me which one of it is an alkane and which is an alkene? I'm inside a dark room. What I can do to distinguish is a distinguish test. Okay, distinguishing test is to undergo bromination reaction. So we say that this is a very good distinguishing test. Distinguish between alkane and alkene. Why? Because if I'm inside a dark room, I have no light, I got no UV light. That means that what? If I react this with aqueous bromine, if I put Br2 inside, I put it into the alkane, it will not decolorize. Remember, alkane only go substitution reaction. They will not undergo this bromination reaction. And hence, the Br2 will remain reddish brown. On the other hand, if I add it to the alkene with the CC double bond, what is going to happen is that because the BR is going to break up and they are going to come here and come here respectively, what is going to happen is that this bromine originally is red brown in color is going to become colorless. I'm so sorry, the pen is not working very well today. Okay, you can see that the handwriting is absolutely not it. Okay, colorless. After the BR have been added into a alkene. Can I? So it's a distinguishing test between alkanes and alkenes. Got me so far? Okay, good. Thank you, Red. I see your thumbs up as well. Okay, now we have not talked about alkenes. Okay, I'm going to cover this last concept on isomerism. And I think some of you are confused about this concept of isomerism. Now, I'm going to quickly touch on this because some of you might have learned this in school already, some of you might have not. But what I'm going to do is that I'm going to just illustrate to you what does isomerism means. Okay, this one just for awareness. If you all haven't learned it yet, this is an introduction. Okay, but before that, somebody asked a question at the back. Now, somebody asked, there is no presence of UV light needed for this addition reaction. Yes, correct. This addition reactions only need number one, hydrogenation need nickel catalyst. Number two, just the solution is enough. And that's why we say alkane are more reactive. Okay, alkene double bond are more reactive because they don't need UV light. They can just react. Can? Okay, good. Now, isomerism is the last thing that I wanted to touch on today. Okay, this one is quite difficult. Now, isomerism in alkanes and alkenes. Now, basically, what are isomer? We are talking about two different compounds, A and B. Now, I got A and B. I tell you both the formula is C4H10. Can you tell me now, type inside the chat, if I give you A and B, I tell the formula C4H10. Can you tell me A and B, are they the same molecule? Are they the same molecule? Yes or no? I just tell you this, they are C4H10. Okay, I see some answer. Okay. Okay, good. Good. Destiny, I see your answer. Meg, I see your answer. Anybody else want to try? C4H10. A and B are both C4H10, but are they the same molecule? Okay, I see your answer also. Okay, anybody else? Okay, got some yes, some no. Yeah, I see your answer as well. Okay, now A and B, it turns out if I got C4H10, they can be different molecule. I'm going to prove to you how does this works. Okay, come. Okay, let's discuss. Now A and B. Both of the formula are C4H10. Oops. Okay, good. Move this here. Now, for 4 carbon, remember I can connect the 4 carbon like that. Then you see, just now I say when we are drawing organic compound, we check for isomer, right? Check for isomer. Basically, isomer is something that have the same formula, same molecular formula, C4H10, but the structure of it is different. So what does that mean? For example, this one actually is not 4 carbon like that. It turns out the 4 carbon is arranged like that. And then after that, okay, the rest of these are all hydrogen. Okay, can you see now, okay, everybody, can you see now that this A and this B, although both of them are C4H10, they got 4 carbon, they got 10 hydrogen, but they are not the same. This one is like that. Then this one is more of like this kind of shape one, right? So you can see that they are different molecules. And what we can deduce is that A and B are isomers of C4H10. Basically, they are the different configurations that C4H10 can take up. So in this case, we will call this C4H10. This is a straight chain isomer. You can see they are one straight line. Now, you can see over here on the B, this is a branched chain isomer. You can see, now it's a straight line with a branch out. Okay, so you can see C4H10 actually, they can be A, they can be B, not necessarily because they got the same formula, they are exactly the same molecule. They can be different molecule. And this is the concept of isomer. They are different compound with the same molecular formula, but different structure. Okay, the way of it, the shape of it is different. Okay, the arrangement of the carbon atom, the arrangement of the hydrogen atom, they are different. Okay, now because of the fact that some of it are straight chain isomer, some of it are branch chain isomer, these different shape can result in different physical properties such as boiling point differences. Okay, so this one is isomer. Maybe when you go back to school, you can actually look at these questions on a greater detail. Okay, I don't have much time to cover this today. Okay, all right. Okay, anyone don't understand this? Need me to explain again? I give you a simple example. Okay, A and B. Can any question? Yeah, if not question, then I move on already. Yeah. Now let's go to here. Okay, let's go to this practice question. Okay, now let's look at this question. They are talking about the three structures of hydrocarbons. Okay, which statement is correct for all three compounds? Maybe let's take a minute to look at this question together. Okay, Matt, you hold your question until the end, okay, so that I can address your question directly. Yeah. Okay, anybody want to try this question too again? Can I give you a clue? It's not option C because you see, I give you, I let you know over here. You can see that the three hydrocarbons, the one on the left-hand side, the first one, okay, let me try use the pen again. Make sure it works. This one over here, okay, good. This one over here got three carbon. Can you see? They got three carbon atom. Then you can see the second one over here, they got four carbon atom. Then can you see this one also got four carbon atom? Okay, so because they got different number of carbon atom, that means that the physical property will be different, right? Because you see this got four carbon, this one got four carbon, this one got three carbon. Because they got different number of carbon atoms, the size of the molecule is different. The force of attraction in each molecule, between each molecule is different as well. The one with three carbon will be less, right? Because they are a smaller molecule. When the size decrease, the force of attraction also decrease. Okay, so hence physical property out. Option C is out. Okay, yeah. Now we try option A. They are isomer of each other. Remember what does isomer means? Means same chemical formula. Okay, same molecular formula. A different structure. Now, do they have the same molecular formula? This one got three carbon. This is C3H8, right? Then this one is what? C4H10. Am I right? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogens. And then this one over here, I got 10 hydrogen, C4H10 as well. So you can see that these are not isomer. A is also out because they don't have the same molecular formula. Means they got different number of carbons, right? Then hence they got no same molecular formula. Now, option B, they have the same general formula. Now, general formula means what? General formula means, for example, CnH2n, CnH2n plus 2. This is called a general formula. This is known as a general formula. Okay, so general formula basically is talking about what? It's talking about if every molecule have the same pattern, and where does the pattern come from? The pattern come from the family. So every molecule have the same family, from the same family, which it is correct over here because they are all from what? Alkanes, right? Because they are all saturated hydrocarbon. Can you see? All these are all saturated hydrocarbons. So in this understanding, option B is correct because they got the same general formula, CnH2n plus 2. Okay, this is a C3H8. This is a C4H10. Okay, C4H10. Okay, option D, why wrong? Aqueous bromine is for what? Aqueous bromine is for alkene. Alkene decolorize. Okay, aqueous bromine. Alkane don't react with aqueous bromine. Yeah. Remember, alkane don't like to react. Alkane only undergoes substitution reactions, and that need to happen in UV light and chlorine gas. Okay. Any questions? Okay, if you can understand, can give me a thumbs up. You understand why B is the answer, can give me a thumbs up. Okay, thank you, Kai Chi. Thank you, Red. Okay, thank you, Vashista. Aaron as well, Destiny. Okay, very good. Well done. Okay, so I hope that you have learned something from this question. Okay, now I'm going to bring you to another question. Okay, let's look at question 3 together. Now, the structure of chloroethene molecule is shown. Which row correctly describe the property of chloroethene? Okay, try this. Young should be quite easy. Okay, good. Thank you, Kai Chi. I see your answer. Thank you, Matt. I see your answer too. Okay, Aaron, I see your answer also. Good. Anybody else? Okay, Destiny, I see your answer also. Any others? Okay, Red, I see your answer also. Okay, look at the molecule carefully. Look at the molecule carefully. My hint to you. Don't fast give me an answer, but you never see the molecule. Look at the molecule carefully. And look at the option. Hydrocarbon. What is hydrocarbon? What kind of thing will react with aqueous bromine? Oh, Kai Chi change answer. Why? Why Kai Chi? Why? Is it A? Why do you think it's A? Okay. Uh, okay. And okay, Kai Chi. Yes, it's an alkene. Because got CC double bond. Remember? Alkene is defined because of their special characteristic is a CC double bond. Okay. Okay, Red, you change your answer as well. Okay, good. Anybody else? Well, I see all the answer. A, B, C, D all have. Okay. I go through. Now, let's understand this from a chemistry point of view. First, look at the figure. What is most important? You must identify there is a carbon-carbon double bond. And that means that it can undergo what kind of reaction? It can undergo addition reaction. Okay, for example, bromination. That means it will decolorize aqueous bromine. Because the double bond can break, I can attach another bromine atom here. I can attach another bromine atom over here as well. Okay, so this is a bromination reaction can be done. Next, because this is a chloroethene, there is a presence of a chlorine over here. Okay, now the fact that there is a chlorine atom over here does not change the fact that it's an alkene. This is just something that is attached to the carbon. Okay, so it doesn't matter. It can just stay here. But what does this mean is that this molecule is no longer a hydrocarbon. Why? Because hydrocarbon, remember, only contain hydrogen, only contain carbon. Chlorine is not part of the list. Okay, and hence, no, it is not a hydrocarbon, but yes, it reacts with aqueous bromine. So answer is B. Okay, those that you all got B correct. Okay, can I? Need me to explain again? Anybody need me to explain again? Those okay, can you give me a thumbs up? Okay, good. Thank you, Mac. I see your thumbs up. Great also. Okay, good. All right. Yes, correct, Kaiji, you are right. Okay, the reason why when we teach you, we say alkenes are saturated hydrocarbon is because you see, alkenes, basic alkenes, is because of the fact that they got this CC double bond, and we attach it all to different or rather we attach all to hydrogen. The default is for us to attach all the other bond to hydrogen because we don't want to make it complicated. We teach you that this is an alkene. Simple alkene, never attached to anything one, always is just based on hydrogen. However, if let's say I change this hydrogen, it turns out this alkene don't have hydrogen, but it have chlorine. Yes, it is still an alkene. Okay, it is only determined by the presence of a carbon-carbon double bond. We say that this is the alkene. Can I see? Okay, okay. Yeah, okay, good. All right. The rest of us, any question? No question. Okay, can for those of us who still have questions just now, I will cover it, or rather, for those of us who have a more in-depth question, if you need me to explain to you again, okay, you can let me know. Then at the end of the lesson, we can address those questions as well. All right. So I hope that in this question you were able to gain some insight on how our alkane actually work, as well as what does all these terms mean, react with aqueous bromine, hydrocarbon, etc. So organic chemistry, you'll realize, is a chapter that really talks about the different terms as well as how does molecule actually move, how does molecule actually react, and what does, for example, like a substitution reaction, what actually happened, the chlorine will come and keep the hydrogen away. Huh? So processes like this you must understand. So for organic chemistry, not to be a memorized thing, okay, not to be a memorized thing. You'll see, okay, because of carbon-carbon double bond, now you know that because got two bond, I break already, I still left one bond. So yes, I can break the bond. I break the bond, I can add two other things to it. Okay, I can add two other atoms to it. Okay, so they undergo addition reactions. So you must have a logic. The logic must flow. All right. Okay. Now, for students who are okay already, that will actually be the end of whatever that I wanted to cover for today's session. Okay, so if you are interested in following us on YouTube or Instagram, you can also follow us through these QR codes as well.